all of you. Today's gate question is, in the circuit shown below, D1 and D2 are silicon diodes with cut-in voltage 0.7 volts. Vin and Vout are input and output voltages in volts. The transfer characteristics is. It is the question under analog electronics. From today onwards, I am going to cover analog electronics questions. Okay. See the circuit. This is a circuit given. You have to find the transfer characteristics. Okay. Yes. This voltage is 1 volt. This is plus and minus. This is 1 volt. Okay. So now we'll start drawing the transfer characteristics of the given circuit. To draw the transfer characteristics, we have to identify when D1 will be on and when D2 will be off. At those times, what is the output? Then you can draw the graph between Vin and Vout. You all know the transfer characteristics means graph between Vin and Vout, means the input voltage and output voltage. Okay. So now we'll see in sequence when the D1 is on and when the D2 is on. Okay. So now see D1. D1 cathode is connected to 1 volt and we know the D1 cut-in voltage is 0.7, means across D1 we have 0.7 volts all the time. Okay. Now how much is Vin to make the D1 on? Yes, the cathode is at 1 volt and across this we have 0.7 volts, its cut-in voltage. So your Vin must be greater than this 1 volt plus 0.7. Okay. Anode voltage Vin must be greater than, yes, 0.7 plus 1, then only your diode gets on, because for the cathode you are supplying only 1 volt. Means your anode must be greater than 1 volt and that too the diode cut-in voltage is 0.7. Cut-in voltage means it conducts only after reaching the cut-in voltage. Okay, so then your Vin must be greater than 1.7. Okay, so and yes, you can write that as Vin minus 1 volt must be greater than 0.7. The difference, this difference must be greater than 0.7. Then only the diode D1 will be conducted. Okay. Or you can write simply, like I said, Vin must be greater than, yes, 0.7 plus 1, that is 1.7 volts. Okay. So Vin must be greater than 1.7 volts. Okay. Then only D1 on and D2 off. Okay. So what is now when D1 is on and D2 is off? Yes, why D2 is off? Because for the cathode you are giving greater than 1.7 volts. Yes, and for the anode it is at 1 volt. So D2 is in off state obviously. Okay. So D1 is in on and D2 is off. So what about output? Already what you applied? You applied Vin greater than 1.7. Okay. So what is V0 now totally? Yes, Vin. This is, yes, you are applying plus here. And this is the cut-in voltage plus minus. And what is Vout now? For this case, your Vout is Vn, yes, the second, yes, suppose if this is like this, Vn, the second terminal plus Vn, and here the second terminal minus 0.7, okay, is equal to Vout. So Vn minus 0.7 volt is your Vout. Okay. So now I'll see the second one. I'll see how the diode D2 will be on. What is the D2 anode voltage? Anode voltage is 1 volt. Yes, again this cut-in voltage is 0.7. Cut-in voltage is like this. It is 0.7. Okay, this is anode, this is cathode. So how much you have to apply? Again you have to go for anode voltage minus cathode voltage, means that is Vn, must be greater than 0.7, like this condition. Anode voltage Vn minus 1 volt must be greater than 0.7. The same way anode voltage here is 1 volt. Yes, must be greater than anode voltage minus cathode voltage, that is, this is the first condition, and the second condition is your anode voltage 1 volt minus your cathode voltage Vn must be greater than 0.7. All the time to make the diode on, your anode voltage minus cathode voltage must be greater than the cut-in voltage. Then only the potential difference will occur. Then only 0.7 volts will be applied to your diode. Then only the diode will conduct. Okay, remember that point. So what is this now? This is, yes, this 0.71 minus 0.7 must be greater than Vn. So what is Vn? Vn must be, yes, okay, suppose this is a 0.3, 0.3 must be greater than Vn, implies Vn must be less than 0.3. Vn must be less than 0.3. Okay, then what about Vout now? Vout, again same, yes. Yes, the second terminal plus Vn, here also the plus, that is equal to Vout. So Vout is Vn plus 0.7. Vn plus 0.7. Okay. So now for these two equations, yes, you have to draw the transfer characteristics. Yes, another point is there. Suppose, yes, see here, Vn is here, it is greater than 1.7. Then diode D1 on. Here Vn less than 0.3, then diode. Okay, so for this condition, yes, what happens for this condition? Vn less than 0.3, D1 off, D2 on. Okay, I forgot to write. Okay, so for this value D2 is on, and for this value D1 is on. Okay, suppose your voltage is 0.3 less than Vn less than 1.7. Means if your Vn is less than 1.7 and your 0.3 is less than Vn, means Vn is greater than 0.3. Here reverse, if in the reverse case, okay, between 0.3 and 1.7, this is for greater than 1.7 and this is for less than 0.3. Suppose if your Vn is between 0.3 and 1.7, what will happen? Yes, D1 and D2 both are in off condition. Okay, so D1 off and D2 is also off. Okay, we know when D1 and D2 are off, acts as open. So what is output? Then if these two are open, your output is simply, yes, your output is simply 1 volt. Your output is simply 1 volt. Okay, so now take all these output equations and then you try to draw the transfer characteristics. Okay, yes, now this is your Vn and this is your Vout. What are the points? Discontinue points, 0.3 and let it be 1.7. Okay, yeah, between 0.3 and 1.7, what is Vout? 1 volt, let it be 1 volt. Okay, so between 0.3 and 1.7, it is 1 volt. Okay, then for greater than 1.7, your Vout is Vn minus 0.7. Yes, actually it is like, yes, this equation is like C, y equal to mx plus c form. Y equal to mx plus c. This minus 0.7 gives the intercept and V of t equal to Vn gives the linear variation. So what about that case? Yes, from 1.7 onwards, your Vout is equal to Vn. Yes, you can draw like this. Okay, but if you extend it back, it cuts your Vout at minus 0.7. That is the meaning of Vn minus 0.7. Okay, fine. Yes, next. Then for this case, means for less than 0.3. Yes, what is Vout again? Vout is equal to Vn. Okay, but the intercept is 0.7. The intercept is 0.7. Okay, see here. this is your V out is equal to V in, but here this intercept is again, this is your 0.7 volt. So here you have 0.7 and here you have 0.7. So see the characteristics. Yes, now you compare this characteristics with the options. So if you observe, your option A is correct. Option A is correct. Okay. Yes, actually in this problem, no need to do the entire problem actually. Suppose if you see these three conditions, see this condition between 0.3 and 1.7, V out is 1 volt. Now you observe the four given options, and which option between 0.3 and 1.7 your V out is 1 volt. See here, only in this. That is enough actually, but to know completely about the concept of this circuit, then you must draw all these things. Okay.
Thank you for watching this video. If you like this video, please don't forget to like, share and subscribe.